Hey guys, it's YouSayIt59 coming to you again with another algorithm for the Bermuda 8 Cube series. Before we get started, I think it would be best if you reviewed my last video because that goes into much more detail of what I am going to do. What I did in my last video was I performed a 3-cycle between this end piece, this end piece, and this end piece. What we're going to do today is do a 3-cycle of this end piece, and this front end piece, all in the same plane. Now, to show you that it's a universal algorithm and can be applied to any of these cubes, I've got all 8 cubes here, starting from the Mercury to the Neptune. So what I'm going to do is pick one of these at random. I'm going to cover them with this blanket. I'm going to mix them up somewhat. And at random, just pick one. And let's see what we've got. We've got the Uranus. And this is actually a pretty good one because this will really illustrate what we need to do. Okay, so let's get started. Now, as I said, you really be helpful to review the previous video because this is essentially the same set of principles. In order to do this algorithm, like the last one, you need to start with an isosceles triangle on top with the vertex facing you. Also, this has to be a right angle pointing to the centerpiece, and this has to be a right angle. Doesn't necessarily have to be a triangle as we saw in the previous video, but it does have to be a right angle, and you have to have all 3 sides freely movable, not blocked. Okay, so the algorithm goes like this. Right, -1, left, right, left, -1. Upper, -1.5, left, -1, upper, 1.5, left. Right, upper 1.5, right, -1, upper, -1.5. Left, -1, upper, -1.5, left, upper 1.5, upper -1, right, upper, right, -1. And this did exactly what I said it would do. This green-yellow triangle moved to here. The yellow-blue-red square moved to here. And the yellow-blue-orange square moved to here where the green-yellow triangle had been. So that was a complete 3-cycle. The rest of the cube is untouched. And as you saw, what this was 5 separate mid-piece series that were unique and non-repeating, that effectively took away the mid-piece series and restored them asymmetrically, thus resulting in a 3-cycle of the end pieces along the way. Now it can easily be reversed, of course, and the reverse is R, U -1, R -1, U. U -1.5, L -1, U 1.5, L. U 1.5, R, U -1.5, R -1. L -1, U -1.5, L, U 1.5, L, R -1, L -1, R, and the cube is restored. Now let's look at the mirror image, which is pretty straightforward in and of itself. It's L, R negative 1, L negative 1, R. U 1.5, R, U negative 1.5, R negative 1. L negative 1, U negative 1.5, L, U 1.5. R, U 1.5, R negative 1, U negative 1.5. U, L negative 1, U negative 1, L. And that's done the opposite. The yellow-red triangle has moved to this corner. The green, yellow, orange triangle has moved to this corner. And the blue, orange, yellow triangle has moved to this point, performing the 3-cycle. The reverse, of course, is going to look like this. L negative 1, U, L, U negative 1. U 1.5, R, U negative 1.5, R negative 1. U negative 1.5, L negative 1, U 1.5, L, R, U 1.5, R negative 1, U negative 1.5, R negative 1, L, R, L negative 1. The cube is restored. Again, you need to look at my other video for more details of terms like end pieces and middle pieces. I don't like to use the term edge pieces or corner pieces because these edge pieces act the same as these edge pieces, and you can see this one lies on the corner while this one lies in the middle, or these end pieces rather. I also talked about in my other video what to do, how to use this algorithm or the other algorithm when a piece is properly placed but disoriented, and how to do a rotation by moving it in and out of the position and then performing a rotation procedure. This can also be applied in the same way, and I'll leave you to surmise how to do that. If there's more interest and somebody wants to leave a comment, I can do a video to show how that's done. But remember, we pulled this one out randomly to show that it can be done on any of the cubes, and I assure you, give it a try. It'll work just as fine as long as you set it up such that there's an isosceles triangle with vertex pointing towards you, a right angle here. Doesn't have to be a triangle, could be a square, and as long as it's freely movable and unblocked, and a right angle here. But it is essential that you have the triangle here because that's important to the actual movement of the pieces. So here's another tool for you to use. I hope you can enjoy it, and I welcome any comments. So thanks a lot.